Hi everyone, welcome to this talk. My name is Shane Bristles. I'm a senior engineering manager at the Lego Group and also an AWS serverless hero.
Hi, I'm Danilo. I'm part of the developer relations teams in AWS. And today we'd like to talk to you about the journey of Lego. And this is the idea continuation of last year's session, where Lego explained how they started their serverless journey. And then we will enter into some interesting details of how they use AWS step functions to orchestrate inside their microservices, and how they use Amazon Event Bridge to build an event-driven choreography of their different microservices. After that, we'll see how the serverless approach they have has an impact on the growth of their team, and also what's the business value of this, because the business value of serverless is not just for the IT department, but it's for the whole organization. Last year, in this session, Lego shared how they started and also how they grow, and they actually migrated their e-commerce website to a serverless platform on AWS. They shared a number of use cases and patterns that you can use if you have a similar problem. You can apply these patterns to solve your own business issues. For example, ideas how to handle a codeless data ingestion using Kinesis data firehose, or how to build an hub and spoke event bus to coordinate their order management. But this year, when I was talking with Shin, he was telling to me how they feel that they're building on top of what they did the year before. They are growing. They're feeling that they are accelerating. So the idea of this session is really to see what this really means. So what do you mean by accelerating, Shin?
Accelerating with serverless. What do I mean by this is when we start working with serverless, there are a few things for us to look into. We need to, of course, familiarize with the technology, to know the number of different services, and then look at the tooling and work on the build and deployment pipelines before we get something to production. So then when we take our service to production, so it could be a POC, or in our case part of the lego.com, we move to serverless. So when we reach that stage, we gain knowledge and skills on serverless. So that gives us a platform from there to accelerate to achieve many things more. So that's what I mean by serverless here. So during this talk, we will see how the serverless services enable this acceleration, and also we will see how the team growth happens, and also how the business value gains from the serverless acceleration. So if you look at the technology acceleration, so when we started, we were not using all the different serverless services available. For example, step functions. So we were comfortable using Lambda functions and a few other services. And then as we gained experience, we started to use step functions. And step functions really helps us to put the workflow, in a better way. So we will see a few use cases where we use step functions to actually really gain benefit during our development process and the implementation. So this is a simple product catalog feed. So we have number of the pipelines we have. So in here we are taking lego.com product data onto different consumers. So it could be the social media, and also we publish to our own backend applications. So this is a important but a simple pipeline. But the important thing to note here is that the platform that serves the customers is also the same platform we will be running the product queries on. So we need to be careful not to overload this platform with a number of queries. So we were looking for a way to smoothen that queries, because we are looking at thousands of products across tens of different countries. For each country, we need to perform the query. So that's where we use the dynamic parallelism of step functions to make this implement in a better way. So here is a simple scheduler which runs a particular step function few times a day. And the step function, the state machine logic itself is very simple. In there you see that sort of three dotted boxes. That's the the parallels dynamic parallelism step in there, and that allows us to control the number of concurrent queries that we can run on that particular platform. So if you look at the script behind the dynamic parallelism, the important point to note here is the map state. So that comes with the number of the total number of, say, countries that we wanted to query the products on. So then the max concurrency limits how many parallel executions we can perform. So this way we can really control the number of parallel executions we perform, and this really helps us here to smoothen the product queries that will be running on this particular platform. So then here is another use case where we have a pattern to replay the failure messages in certain cases, and in there we use step functions as well. And if you look at this again, a product, data feed pipeline. So taking products from Lego.com, the updates needs to be given to the recommendations team, which is another part of a Lego group, and they then provide the product recommendations for the customers visiting Lego.com. And if the pipeline fails for some reason, then we need to capture those failed feeds separately, and then as soon as the API is back to serving the request, then we need to resend those failed requests back to the recommendations engine. So this is a simple workflow, but there are a few things that we need to make sure that when we handle reprocess the messages, so that we don't send duplicates and things like that. So this is a simple flow. As you can see, the product feeds are coming to the bucket, and from there there's a lambda function that processes the feeds and then sending out to the recommendations API. So if that goes down, then there is a DLQ attached to the lambda that captures all the failed messages. It also sends a message to the event bridge bus. The event bridge bus then has a consumer to take that failure message and sends off to the team's channel for notification. This is completely a different service, and there is the state is maintained in a parameter store, so that keeps the status of this endpoint. And when that becomes available again, so when everything works again, so there is an event sent out to the event bus. So consuming that event is actually a different service that then will fetch any failed messages accumulated in the DLQ and then start replaying the messages. So if you look at the state machine, so the state machine is basically fetching the messages, and it will make sure that there aren't any duplicates, and then it plays the latest messages. So it's as a whole, it's a circuit breaker pattern. It's very common in serverless, and within the pattern we have the state machine playing the part to replay the messages. As you can see, there is also a dynamic parallelism in use in this particular case. So this is again another use case where we can combine different services to implement better patterns to take care of failures and make your application perform better. Right, Event Bridge. Event Bridge is an amazing technology. I remember sitting next to Danilo at the Serverless Days London last year when Event Bridge was announced, because Event Bridge fills in the gap of the event-driven computing in serverless immensely. That's why we started to adopt Event Bridge as soon as it was announced, and then slowly, gradually, we put that in place. And now Event Bridge is part of our ecosystem. Every service that we develop has event bridge contribution in there. Now, we will look at a couple of use cases. So here is a feature we recently developed. It's a back in stock notification. Customers coming on to lego.com looking to buy Lego products. And then they see that a certain product is out of stock. And there is an option for them to get notified. So they register for it. And in the background, there is a service that is basically looking at the different products statuses. And then when products become available, that there is a new process that then fetches the emails, notifies the customer. It's a simple, process. But how we can, make it event driven with Amazon Event Bridge is what it gives the speed when we developed this particular feature. So here is a picture of different microservices associated with this feature and the different messages, the events that flow around. If you look closely, then we can see that EventBridge in the middle acting as the coordinator. And then, so we have the one service that takes the registrations from the customer and that sends an event to the bus. And that event is then consumed by another service, which basically stores the emails in a DynamoDB table. So that's fine. Then completely attached, different to this setup, there is a service which is actually looking after the product status. That service keeps sending events to the EventBridge bus. Then when a product becomes available, that particular event is now consumed by a different service that then starts fetching the relevant email addresses and then forms the email content, pushes to a queue, and then will be sent off to Amazon a simple email service, which acts as the email sender for us. So that completes this flow. But the advantage using SES is that for every email that we send, we can configure it to receive a feedback. So feedback to come back to us. So which is really good in terms of business analytics and to know the insights and the efficiency of this particular feature. So that again comes back to us and then again fed to the event bridge. So as we can see here, the event bridge really coordinates the different microservices to communicate between them. So it's acting as the choreographer in this particular case. Now, if you look at the microservices, the dotted boxes, and the highlighted box is a microservice. As we can see, it has a step function, state machine flow within itself. So basically what it's is doing is to look at DynamoDB, look at the number of registrations there are, and it iteratively fetches and then forms the emails and sends to a queue. As we can see, so this particular state machine is orchestrating this flow, but that is within inside a particular microservice, which is actually choreographed by EventBridge. So this is how the EventBridge enables this event-driven computing. And I mentioned the feedback coming back from the emails, so SES. So we have a pipeline to ingest that event. So we use Kinesis data firehose for that purpose. So the different type of feedback events are like you reject, bounce, and send, click, open, etc. So this event data coming back, this is very important, as I mentioned, for the business insights. So we use data firehose, and that means we can batch the events and then the events get dropped into an S3 bucket. That then triggers a Lambda function, which will then process the events and send off to EventBridge. What we do here is that instead of sending each feedback event as an EventBridge event, we batch the feedback events and send batch events as a single EventBridge event to EventBus, and then there are consumers and acting upon the events. So this is a pattern actually that really helps us here, in a way, not to overload with events, but put them together and then streamline the event routing accordingly. So there's sort of patterns that we use here and to enable that the event delivery mechanism. Now, if you look at this particular the highlighted part, this is a well-known, very powerful data ingestion pipeline. And we already have this pipeline ingesting our clickstream events from Lego.com. So this became fairly familiar for us because then we were able to use that same pattern again here, and that itself gives us the momentum or the speed when we develop these services. So it's very, very common that you see a number of serverless patterns being available in the industry, and also when we develop, we come up with our own patterns. So all these different things help to accelerate our development with the serverless. And I wrote a blog post detailing this particular, the backend stock, and it goes through a number of details how the event-driven mechanism, can be really used with the event bridge to take it to, the next level. Now, here is a different use case. So this is an order placement flow. So it shows a few microservices. Of course, there are many more, but just for our discussion here as a simplified microservices here. And at the center, we see that Amazon Event Bridge, acting as the coordinator. Now, an order placement goes through a number of stages. So when an order is submitted, it needs to be the payment needs to be authorized. So there's a payment service that receives the event, and that then once authorized sends out an event, then the order processing service takes care of it, and when it processes the order, if everything is good, then it sends out an event, and then the shipping service takes care of it to dispatch the order to the customers. Now this is a happy path flow. Now, what happens if something failed in the order processing? When something fails, we need to know, the other services need to know, because they need to revert certain things. So a cancellation event being sent out, and the payment gets canceled, and the order, then the information goes back to the front end and to the customer. Now, as we can see here, EventBridge coordinates the whole microservices communication as a choreographer. But if you focus on that particular order processing service, at its core is actually a state machine. And that state machine basically goes through a number of validation steps in parallel. And also it has a failure step. And there it will send out an event if something needs to be rolled back. So then the other services will then react upon that, and then the order will get a rollback, and the details will be reverted. So this is again another example how EventBridge and how EventBridge coordinates the microservice communication. Whereas when we focus in a particular microservices, the step functions takes over as an orchestration mechanism to run the workflow. Now, that leads us to choreography versus orchestration. So for this slide, I will invite Danilo back to talk about orchestration and choreography.
Actually, what we just saw is an example of choreography versus orchestration. And when I talk also with other customers, I see that they often use choreography when you don't have a single agent monitoring the whole coordination process to coordinate different microservices together. So an event-driven approach with a tool like Amazon Event Bridge works very well. On the other side, sometimes you need an orchestration that is strictly controls what happens, for example, inside a microservice, or when you want to coordinate something like a distributed transaction, when you have multiple microservices that either they work all together or they don't. In this case, a workflow managed, for example, by AWS step functions works very well.
Okay, so we have seen how the technology accelerates. Now let's see how the team growth happens in a serverless environment. Now, when we started serverless, we started with the one serverless engineer, then grew to and up to 10. Now, at that point, we had all the engineers working in one team. That really helped to to evolve the different services and also to grow the knowledge within the team. So the communication was helpful to make the engineers learn and become experienced with the serverless technology. And then as things grew, then the team kind of evolved, and we had number of new teams, or what we call squads, came up. So at this point, we were able to distribute the serverless knowledge onto different teams now. So they are now more feature driven full stack teams. In almost all the teams or the squads, we will have serverless engineers and other engineers who gain the knowledge every day. So that means anybody can work on the serverless and also on the front end. Of course, there are certain teams who will have more serverless focus because they focus on backend services, but that's what we are trying to get to. Now, this is another beauty of how the team grows when the serverless ecosystem grows. Now, in doing so, the knowledge grows, and we also make engineers become aware of architecture, and they are part of the DevOps process, and also they get the ownership the concept, and they become responsible to the services they built, and they become aware of the practices like a well-architected framework and serverless lens. So this is really another phase of the serverless growth. And then let's see how the business value acceleration happens. Of course, it's good to have all the technology and team, but for business, we need to look at how the value gain from these serverless. So here are a few, graphs from the production system. Now, the numbers may not represent anything. Say, for example, if there are number of, high number of sessions, we can say that there are high number of customers on lego.com. That means we can expect a high number of orders to be placed. So, and when we have a serverless technology and the platform that can scale and deliver this, it really becomes advantages for the business to gain more value out of it. Now, the reason, because we can now deliver features faster, and that's the beauty of the serverless is growth. And that means stakeholders can be confident enough, and confidently they can approach the teams to deliver more features and solutions. And also that gives more operational visibility to everyone in the business, which is very, very important. And above all, with a scalable and serverless platform, we can serve millions and millions of Lego customers who are adults as well as children all around the world. Thank you so much for listening, and please fill in the survey.